All right. Uh, Welcome. Uh, in today's lesson, we are going to solve one example about Newton's law of motion. Yeah. So from the previous videos, we were talking about Newton's law of motion and the laws you can use in order for us to arrive at an exact answer and for us to actually solve the problem involving Newton's law of motion. All right. So in today's lesson, you have been given a question one, which is an example one. Which state? All right. So the question states that an object of mass 5 kg is suspended in an elevator using a spring balance. What does the spring balance read? If question A, the elevator moves upward with uniform velocity, the elevator accelerates upwards at 5 meters per second squared. The elevator moves downward at 3 meters per second squared. So I've been given a question which needs us to do what? To answer correctness. So, in first and foremost, as we are not talking about the how to use the laws of Newton's law of motion to do what, so that we can answer the question correctly. So first of all, we said we need to convert all the given masses into what? Into newtons or weights. So I've been given the 5 kg. I've been given 5 kg. So now this 5 kg we need to convert it to weights. What's the formula for weights? We said the formula for weight is times mass times the gravitational force. So weight is what we are looking for. Then mass have been given. The gravitational force, it's the constant number, which is 9.18. So again, to plug in, we say weight is equal to 5 multiplied by 9.81. So you are going to get your calculator. So that's 5 times 9.81. That is 49.05. The answer 49.05 newtons. So next, we said we need to list down what you have been given. So we only have been given the mass, which is 5 kg, the weight which we are just from answering, which is 49.05 newton. So this is what we have been given. And we need to draw a free body diagram. So the question reads, an object of mass 5 kg is suspended in an elevator using a spring balance. So we can assume that this is a spring, this is an elevator. This is an elevator. Then inside here, there's a spring. There's something like this. So this is an elevator. So this is a free body diagram. So we can this is the same as drawn like this. We have something which is pulling up, and we have something. So this box is a 5 kg box, and we have a weight. This weight which is bringing this object downward, which is equal to weight, which is equal to 49.05 what newton. Then we have upward here, tension. This is the force in the string which is opposing the motion of this of this box. So now the question reads, question 1 says, so question A, we're going to answer it. The elevator moves upward with uniform velocity. For us to answer this question, we need to go back to the linear motion. When we say an elevator moves upward with uniform velocity, in a linear motion, we say that when an object moves from this point somewhere to, let's say this is 0 and this is 20. When an object moves from 0 to somewhere here, which is 20, this object, it is not this is not velocity, this is an acceleration. It has accelerated from 0 to 20. When it moves somewhere here and it retardates, this period A to B, this period from A to B, this is a uniform velocity. This is a uniform velocity. So this is what you're talking about. And when you say this A to B is a uniform velocity, meaning there is no acceleration here. Meaning acceleration is what is equal to 0. Acceleration when it takes you from 0 to A, this is where acceleration is, because it has accelerated from something which was not there to something which has what it has become. From 0 to 20, this is acceleration. From 0 to A, this is acceleration. And from A to B, this is the uniform what velocity, or what constant what velocity. So here acceleration is equal to what? Is equal to 0. So the formula we're going to use force is equal to mass times the acceleration. So here where is force, we are going to replace it with these figures. The question states that the elevator moves upward with uniform velocity. So this is an elevator. There is weight going down. Again, there is something which is pulling upward. This is tension and this is W. So elevator is moving upward. The elevator is moving upward. The elevator is doing what? The elevator is moving upward. So when it is moving upward, here where is force, we are going to replace it with T and W. Now, look what is happening here. It is doing what? It is moving what? Upward. This one is pulling what? W. So T is pulling what? Is pulling W, and is equal to M times the acceleration. So we're going to say this one is the one which is pulling W. So we are going to, so this one will be against, because this one is going what? Is going upward instead of going downward. So it is going upward. So as it is going upward, it's going to be minus. So this is the formula we're going to use as we are going to answer question 1. So the elevator moves upward. So we're going to say T minus W is equal to mass times what? Acceleration. We don't want the tension because the tension is what we have been asked for to do what? To answer. So we're going to say T minus what is weight? Weight we have already answered. Weight it is 49.05 Newton is equal to what is mass? Mass of given the quotient, which is 5 kg, times acceleration. We said when in the uniform velocity, acceleration is what? Is equal to 0. So we're going to say tension minus 49.05 is equal to what? Is equal to 0. So what is tension? Tension is equal to, this one will go to this side, and it became what? It became positive, and we say 49.05 do what? Newtons. So this is question A. We have answered the question A. We are now going to question B.